Hey guys, hope you're doing well. Have you guys ever wondered how exactly does Flutter work under the hood? Like, why does me writing a program in Dart actually create an app that can be run on both Android and iOS? Well, I had the same question, so I got to digging. What I found was this term called Flutter Engine and this scary looking architectural diagram to back it up, which of course did not solve my doubts at all. After a long time of actually scrambling through the documentation, I figured I'd create a video on what exactly is Flutter Engine. So, hope you guys enjoy this video and find it informative. So, what is the Flutter Engine? Flutter Engine is nothing but a container or an environment that is required for a Flutter app to run. It contains three main components. The first of them being the Dart virtual machine. Then it's the renderer, which is responsible for basically displaying the widgets on your screen. And lastly, a platform specific embedding APIs. Now that we know that, let's get a little deeper into what these things actually do and how they work with each other. The Flutter engine is built on top of the Dart programming language and its associated virtual machine or VM. The Dart VM's primary responsibility is to execute and manage the Dart code that we write. It has two main types of execution or executing Dart code. The first being AOT or ahead of time compilation of the Dart code, and the second one is JIT or just in time compilation of the Dart code. In the AOT mode, the Dart VM compiles the code ahead of time, producing a native executable, whereas in the JIT mode, the Dart VM can compile the code on the fly. This is the reason why Flutter supports the hot reload feature. One of the most important things that the Dart virtual machine actually does is maintain something called a widget tree. A widget tree is nothing but an hierarchical representation of the widgets that we've written in the code. During the runtime of a Flutter app, Dart Virtual Machine also provides important features such as garbage collection and asynchronous execution of code, which is very important for modern web and mobile applications. Another important component of the Flutter engine is its renderer. The renderer, or also called the Flutter rendering engine, its main purpose is to take the widget tree that the Dart VM has produced and create a set of instructions that can be used to render or display the user interface or the UI. This is where the second piece called Skia comes into play. Skia is a cross-platform 2D graphics library developed by Google. The primary responsibility of Skia is to take the instructions provided by the Flutter rendering engine and use it to actually display the pixels or the huge user interface on the screen. Flutter uses Skia as its primary rendering engine across all the platforms, which makes sure that the Flutter app that you are using looks and feels the same regardless of the platform that you're actually using it on. The last piece of the puzzle is the platform specific API layer. The API layer is basically a bridge between the Flutter engine and the underlying operating system. It's responsible for basically handling platform specific tasks such as maybe rendering a native UI widget or handling input events. Now, the Dart virtual machine and the Scale renderer that we have discussed before are platform agnostic. What that means is that the component or the implementation of the component does not change irrespective of the platform that it is running on. This is different for the API layer. There's a different implementation of the API layer for every platform that Flutter runs on. For example, on Android, the API layer uses Android's native development kit or NDK to talk to or communicate with the underlying layer, whereas on iOS, it uses Apple's native APIs. Now that we know how Flutter Engine and its components work in theory, let's take a practical example to understand the flow a little better. We're just going to take a very simple example in this case. The Flutter app is basically a one-page app with a text indicating the amount of times that we've actually pressed this button that you can see on the bottom right-hand side. Now, if you take a look at the code, that's also very simple. Inside our main function, we just have the run app and we're running the my app over here. My app is nothing but a stateless widget that has the material widget that's returning a material app, and the home is set to my home page. Now, my home page is nothing but a stateful widget. One of the main things that my home page is actually doing is keeping track of this counter variable. A counter variable, as you might have probably guessed, is what is actually being displayed over here, which is keeping track of the amount of times that we've actually pressing this button. Then there's the void increment counter button, counter function, sorry. This, as you can see, has a set state call, which increases the counter every time it is called. Lastly, we have the build function. The build function is quite simple. It only has so it's returning a simple scaffold. There are three main parts to it. It's for the first is the app bar, which displays the title over here. The second is the floating action button, which is over here. As you can see on the on press, we're actually calling the increment counter function. And lastly, we have the body of the scaffold. The body can be boiled down to a column of two widgets. One is the text which says you have pressed this button these many times, and the other is a text which actually indicates the number of times that we have pressed, which is actually taken from the counter variable. Now that we understand how the code looks, let's get on with the next part of it. Now, if you think back to the time that we discussed the Dart virtual machine, you might remember that one of the main responsibilities of the Dart VM is to maintain something called a widget tree. Now, if you are using Android Studio, you can just click the Flutter Inspector tab on the right hand side to open and see the widget tree. If you're using Visual Studio Code, some other ID, I'm sorry, but I do not really have the instructions, or I do not really know how to do that. But I'll post a link somewhere on the screen over here so that you can follow and do that. Get Flutter Inspector working for you as well. Now, let's see what the widget tree actually looks like. Every Flutter app actually starts with the root widget, as we can see over here, under which we can see the My App widget that we have under under the Run App command over here, which has the child Material app, under which we have the My Homepage stateful widget that's over here. Now, the My Homepage stateful widget, of course, is returning just a scaffold with three items. The body, which is basically returning a center. Then there's the app bar, and then lastly is the floating action button. Now, the widget tree is responsible for basically maintaining and refreshing the states of the widget whenever something changes. So, for example, whenever we click the button, the My Homepage State app actually gets rebuilt to actually show this change. We can actually take a look at this by actually clicking the Flutter Performance button right over here. Once over here, you can just turn on Track Widget Rebuilds, and you can actually see every time you click on it, you can see these loading icons that are actually rebuilding the widget. So once the Dart virtual machine has actually built the widget tree, the responsibility now goes on to the Flutter rendering machine or rendering engine. The Flutter rendering engine basically takes the widget tree, parses it, and converts it into something that the Skia 2D graphics library can actually understand. So once the Flutter rendering engine has done its job, it's passed on to the Skia renderer, which then actually places each and every pixel that you actually see on the screen. This includes the text that increases as well as the button that you see here and even the colors. So now that we know how the widget tree helps in this, what actually happens when we call set state or basically press this button right over here? How is it actually getting updated? So when we call this set state, we know that the widget tree is actually getting updated. These updates are passed on from the Dart virtual machine to the Flutter rendering engine, which then passes on these updates to the Skia renderer to ask it to basically show the new changed text over here. Lastly, let's actually understand how exactly does Flutter know when I'm actually clicking this button. So to understand this, imagine that the phone screen is basically like a huge grid. Every pixel is its own coordinate represented by X and Y. To visualize this a little better, I've actually added some code. On a high level, what it is basically doing is every time we actually click somewhere on the screen, it's basically printing the output or the X and Y coordinate on it as a debug. So if we take a look at this debug, we can see that it's actually printing this X and Y coordinate. Please ignore this null check code. It might be some other problem. But whenever we click over here, for example, it shows the X coordinate and the Y coordinate. So for example, on the top left corner, it's closer to 0, 0. So as you can see, whereas in the bottom right corner, it's getting much more bigger. So similarly, when we actually click the button, it actually has its own coordinate, which is over here. I can show it again. Yep, like this. So on a high level, Flutter knows exactly due to the widget tree and the Flutter rendering engine, which where these widgets are mapped when in the coordinate system. So when the underlying operating system actually gets a touch input in the form of this X and Y coordinate, this is passed along to the Flutter engine. So since the Flutter engine now knows where we have actually touched and also knows where the widgets are when compared to these what we've touched basically, or when compared to these coordinates basically, it knows what we've actually clicked. So in this case, when since the widget coordinates actually match with the touch coordinates, it knows that we've actually clicked on the widget, and it basically calls the on tap function of the widget or the on press function of the widget. I hope you guys understand a little bit of how exactly Flutter Engine works. If you have any questions, please leave a comment below and I'll try my best to answer those. Other than that, if you like the video, please leave a like. Thank you so much for watching, and I'll see you guys in the next video.